start recording. Sorry about that. Now I'm recording. I'll run through so we have sector-wide programs in post-secondary, K-12 schools, healthcare, and then of course, municipalities. So this is a pilot. This is a rerun of a pilot. A number of you have seen these slides. We have presented them in a number of forums, and we do have a webinar online. If you wanted to go check out that recording, might be helpful because our senior engineer is also there too for a more technical, in-depth look at some of the measures. That we have a recording on our website for that. So this was the roadmap to net zero ice rinks pilot. We started this in 2019 out of an annual meeting we had with all of our members. We're looking for action, how to take immediate action on net zero. It feels like 100 years ago, but it really was such a short 4 years ago. It took us about a year to get everything underway. The pilot was funded by FCM and has informed the CBR pathway to net zero process. So they were developing their process at the same time as we were running the pilot. So a lot of the funding, as Adam said previously, we borrow from each other. They borrowed from us, we borrowed from them, and it was a bit of a mutual evolution process. There we go. Sorry, technology. So I don't have to tell you guys that this is a group effort. We had a lot of people involved in the pilot. We had some experts we had a few people from Les Quinton from the town of Black Diamond who'd been single-handedly measuring every single thing about ice rinks you could imagine, plus putting solar on everything he could find in Alberta with a lot of snow. It was impressive. Getting anyone we could into our technical group to help us move this along. We had industry support, and we really brought industry into each and every workshop we held. So these people really helped us out, for sure. These are the participating municipalities and the rinks that participated. You recognize these, a lot of you own these buildings, know them well, and so these are the participating municipalities and rinks. Nice cross section. So why do we start this project? This was really member driven. People were trying to set carbon targets for individual buildings. We were trying to determine how we were going to implement net zero changes without budgets, which is that net zero over time approach, which was developed through the pilot project. We wanted to build the case for implementing low carbon measures, introduce integrated design into the process, and to start collecting some metrics. How do we know if this is over-designed, under-designed? Is this what differentiates a highly effective ice rink from a low efficiency ice rink? How's a high performing one? What's a low performing one? We needed to start collecting those metrics. And that work is ongoing as we keep moving along. And we wanted to support all of you who really were asking for help in bringing your asset management group into the planning process. So it's great to follow behind Adam and everybody else who's already done presentations, because this is kind of the backdrop to that. This was a few years ago. So this will be familiar to any of you who've done a decarbonization study, especially if you're using FCM funding. There's data collection, site visits, a measure review, which we do collectively with the facility group, and then integrated design workshops, one with the whole facility team and all the experts, and then another with capital, where we do them sometimes together. Capital review workshops where we really look finally at what we decide and how that's actually going to get implemented. The purpose of that is, as many of you have talked about, getting your internal teams on side. One of the things we found through the process is how capital doesn't talk to operations. It seems so logical, but it's that schism. And we talk about these really simple barriers. It seems very obvious that they should work together, but it doesn't happen. And the larger the municipality, the more disparate that those processes seem to be. So getting everybody into the room seemed like a key opportunity to have that conversation. And then we had final reports. At any time, if anyone wants to jump in with experiences or thoughts on how this worked out, would appreciate it. So our overall finding, which seems quite obvious now, but we were able to prove that net zero carbon emissions is achievable and financially feasible in Rinks, especially if you do it over time. Needs an all-encompassing evaluation. You have to look at interrelationship of measures, how they work together. Life cycle costing is key. And we talk about certain shifts that are required. And one of them is that we start looking at life cycle costing as a way of evaluating projects. Looking at maintenance costs, operations. We also looked at training, other opportunities, and those kinds of things. And timing of measures is really key. Okay, so these are the hard numbers. But Kathryn's here because she can speak to them quite in detail. But this were the size of the ice rinks and the pads, gross floor area, number of pads, months of ice in, number of refrigeration plants, et cetera, and it just gives you a great sense of how totally different these ice rinks were. I mean, we had fairly new ones, we had ones that were almost 100 years old, we had everything in between, which is reality. I mean, that's what you guys face all the time, is got your brand new fantastic ones and ones that have been around forever, and how you're going to manage that, for sure. One of the interesting things that I'll just interject in here that I only found out recently is that a number of ice rinks have heat recovery already because they've purchased EcoChill or other similar refrigeration units, and they're not turned on and they're not being used. And one of the big ahas for us out of this is how much there still is in terms of operational savings that can be done immediately. And that piece, some of you already know that, and some of you are just in the process of working through that, whether through doing your own commissioning or that sort of thing. But to me, it was like, wow, we have the technology already installed and it's not turned on. It's incredible. And those numbers are crazy, like 30% of the installed across Canada, they have heat recovery and they're not using it. It's just not turned on. It was never considered. Yeah.
Why would they not turn it on?
It's a great question. I think we're just at the beginning of understanding that. Apparently has to do with additional funding required for the heat recovery to be used elsewhere in the building. And so you run out of funding, so it's in the refrigeration unit already, but it isn't actually ever used for heat recovery because you just ran out of budget.
Okay, so you need to install the next piece of equipment to actually use it, and that never happened.
It never. Okay. So in the original design, you think, oh, we're going to do heat recovery, or maybe it was just never envisioned, but they come with heat recovery in them already.
Okay.
Yeah, that's fascinating to me too. It's like crazy. It's like incredible. This, just for context, setting in your own when you're doing your own net zero plans, it's interesting to see where they are now and then where they're going to end up. So this was really hard to see in this is kind of where the EUIs of where they were when we did the study, and then the target EUI, that's sort of the range. As you can see with that, that's quite a big range in terms of efficiency or how much energy is being used on a square foot basis. And the split between electricity and gas. Any questions? Adam, you got a furrow. Is that just
Jillian, I'm
it's
curious
just all
for,
opportunity. Yes.
for ice rink number 9, I'm just curious from this there's still gas in the system. Why in that kind of ice rink was gas still in the target? Like what made that ice rink different from the rest?
It's a great question. And this is, I mean, so much of this is your lived reality. The municipality submitted this ice rink as a perfect opportunity for net zero ice rink. And during the process, the municipality decided that they were going to tear down that municipality. So we were only looking at operations. So no retrofits were going to be done. So the difference between the 35.8 and the 23.2 is entirely operational because they were going to tear down. They had that building had a shelf life of like 5 years.
That makes sense.
Yeah, so that's what that is. And then I believe, if Adam wants to speak to his building, we really pushed the envelope with Adam's building because that's what you asked for. I think you're number 6. Yeah, so sorry, you're number 7. Yeah, you asked for 100%. How did you get there? Yeah.
In the parking lot, which would take up most of the parking lot, so.
Who needs parking? Who needs parking? Okay.
Out of curiosity, curiosity for the fact that you need, like, the parking would have taken up the whole, PV installations would have taken up the whole parking. Was there any discussions about making the PV panels like above the parking? As like just to have both purposes used for it?
I don't think we designed, I think we consider it ground mount and look at the footprint, and we actually do have enough space. We have a massive parking lot. This is our OHL arena, so it's very large. And when I say the whole parking lot, it's a good chunk of the parking lot, but it's not covered parking. It's the panels. Yeah, we didn't consider it.
Yeah. Great. This is the range of, this is just looking at it, same target greenhouse gas emissions going from what it is today, what they are today, or what they were when we did the study, and then the target greenhouse gas emissions at the end of the study. And then this is, I'm not sure everybody does this, but we've been doing this for a long time, is to really compare system metrics. We find often, and this is a challenge if you're deeply embedded in operations, that they're over-designed to begin with, and that so here we're looking at the compressor. So obviously Rink 1 has a lot more compressor power than Rink 5 on a square foot basis. So this is this is comparable. And how much do you really need? Because engineers do tend to over-design. Our shop is full of engineers, and they know that unless you push, you get over-design just because you're worried about capacity and designing for the worst case scenario. The engineers love to design for the worst case scenario. Yes, please.
Sorry, just a question on that. With that metric, did you also consider how many months a year they build ice in? Because that could be a factor in the compressor power per square foot.
I think this is from nameplate data, so it might be, yeah, you're right. But it's a good question. I'll take the note, but I'll remember that and get back to you on that one, because I don't have that technical information, but yeah, I'll ask about that. And if anyone's more interested in how we did that, be glad to get our technical folks on that. We find this is super useful, because then when you're going into design new, you don't want to be at the top of that list. You want to be down. You want to have the most efficient possible. You want to have the best pumping power per square foot, like the lowest watts per square foot, because that's going to, when we talk about upgrading our electrical systems, because you need a lot more electricity, that's going to come into play. We did the same with dehumidifiers and lighting. I was shocked with the lighting. Like, here we are, it's 2023, and that's a ton of opportunity in Rink 3, because that's really high watts per square foot. And sometimes you have to go back to basics. When people do lighting retrofits, you just do like for like. And when you're looking at LEDs, you really have to redesign, because LEDs don't function like T8s if you're taking them out. It's an obvious statement, but you can see the difference in watts per square foot. Okay, and then this was just a breakdown of a bit previous slide of where the reductions happened in what systems. So per Rink, where we were looking at the reductions. I think Ice Rink 9 was the one where we had the fewest reductions. So you can see that's the one that's just operational. Okay. And overall, this is where the emission savings were to be found. Not surprisingly, most of it's in the refrigeration plant and that upgrading, a bunch on the heating, 17% on the resurfacing. This was looking at cold water versus hot. I think, which is it's not a super difficult retrofit. I understand, more of a human overcoming the way operators like to resurface their ice, as opposed to so there's that. When we talk about how you get people on board, that's a big one that we found. You needed people on board. I think Caledon, if you want to pipe up, you were good. We use you as an example through many of our resurfacing conversations, because you've already done that.
Yeah, well, maybe don't need the microphone here. I honestly don't have too much information on, I do know we struggle with our building operators using like the real ice system.
Yeah.
Pretty plain and simple from our perspective. Like, I know they work. I'm pretty sure they use them for like NHL ice rinks and stuff. So the science is there, the math is there to back it up, but they just like the way the ice is with hot water. versus, I don't know. There are some technical aspects to it, like it needs to be a certain like pressure for it to work properly. Like there are, some complexities to it. But yeah, overall, we've definitely had some issues with building operators getting on board with the system for sure.
Right.
Yeah.
Sinead.
For the cold water flooding, we have had challenges with the operations team. So for us, the challenge has not been so much of their change in mentality. They've been complaining about quality of ice. And they've said that we have a lot of tournaments that go on and we just can't afford, we're not getting the same quality of ice with this real ice system. So that's one of the challenges that we're facing. So that's why we have to take it out of the Susan Fennell retrofit. And we just don't know how to work around that. Is it really a quality issue? Is the system getting better? So we're stuck on that.
Yeah, I think it's oh, go ahead, Adam. No, all I was gonna say is, yeah, it's definitely an ongoing conversation and it's difficult to ascertain. I'm not an ice expert, but that ongoing conversation and technology may fix it. It may not be real ice or whatever other, it may be something else, but that seems like a logical way to use cold water instead of hot. Yes, go ahead.
We have a real ice system that's now on its third location because the first one, it didn't work, and the second one, it didn't work, and now the third one, it kind of works. The biggest challenge is that one thing you need to do is you do realize you have to raise your temperature of your ice, and that's really challenging for some operators. And there's a few nuances that they need to do in order to not have shaling ice or bad quality. And if they don't fully buy into all the components, you will have issues operationally. So this is the second year next fall that we'll be going into the same facility twice. So we're hoping that will help resolve the operators there, but they did add heat to it. So it went, instead of doing cold, they're running, I don't know what the temperatures are, maybe 80.
Indoor airspace gets below 32, you have to temper your water to approximately 45 Fahrenheit. Those are in the details of the real ice instructions that sometimes people brush by. But what we found out is once staff increased their slab temp from 20 to 21 to 23.5 to 24, the shaling concerns went away. The freeze rate and how fast it froze was a lot better. Complaints went down. Energy went down. We sub-meter the particular East View Arena. So it got better by the end of it. So the second time we go around should be great. So it's some negatives, but a lot of positives and learning along the way. So feel free to reach out to us.
Thanks. So again, dehumidification was a big one. Ventilation, obviously. Dehumidification was a huge one. We're now, a few of you are involved. We're moving on to a cohort project looking at pools, and dehumidification has been bigger in pools. Renewables, enclosure. We did look at enclosure. Difficult to make the business case in existing always, maybe particularly the range of rink, but yeah, we had trouble. We struggled with making the economics on the enclosure measures. Water and lights, that breakdown. So
Oh,
this is just
Jillian, one question with regards to, with the selection of the arenas, was there criteria with regards to how those arenas were selected? And in terms of the economics, like did these projects have to have operational savings that would pay for themselves? Or was the criteria net zero emissions? Was the criteria positive rate of return over the life of the asset? Or a combination of the two?
So the arenas were chosen by the municipalities, not by us. We had no criteria. This was really
Okay.
Starting from scratch. No criteria from our perspective. It was mainly from each individual municipality selected which arena. And there were reasons, there was some back and forth, and we spent a lot of time talking about it, whether it was, there's a lot of renewal coming up. So there's opportunity to add on and to make different choices rather than like for like. That came into play, or whatever the reasons. A very high profile arena. One of the reasons we'd chosen arenas originally for the pilot is because they're usually your highest GHG emitter if you don't have wastewater treatment plants or other wacky things. And then the other is that they're really high profile, is that's where everybody comes in your municipality, especially the smaller you get. They're the one big building everybody comes to. It's also why FCM's hyper-focused on them as well. In terms of, we were trying to make the business case for each one of them. And so that was the idea, is to have a positive return using life cycle costing. Yeah, that was our end goal as we worked through the process to do that. This is our little, we had a 30-year period that we looked at them over. It was taking us close to 2050, which were big goals at the time. And when we started the pilot, a few people had climate emergencies, but not everybody. So we sort of used it about 30 years. And this is just a plug for life cycle costing. I won't delve into the details because I'm sure you've had many conversations about how to do life cycle costing and what goes into that. And so this was the aggregate of what we found. So by measure. So it's interesting to look at on a by measure basis. And one of the things I will say is that these costs were in 2021, I think, 2021. And some of our participants have already found that these are out of date because costing has gone wild with COVID. So we were looking at in COVID costing, and even in that short period of time, these costs may be already slightly out of date. Something we've mentally made a note for in our next pilot project is look at the costing and inflation and other pieces as well. So as you can see, that's the difference, showing the difference between the business as usual, low carbon approach with funding, because that was there was the green, there was a whole bunch of funding available at the time, the green renewable, the federal funding available. And then there's also the FCM funding as well. So what the difference, what the business case looks like with funding, without funding, and then the overall savings and where they were, what measures you could find. So this is illustrating the overtime approach. It's numbers, so the engineers did this one. I'd like to make it a bit more visual, but it shows you when the big implementation periods happen. So essentially, big 2023 implementation, because this was in 2021 when we did it, 2024. So when you're implementing measures, the big cost outlays, and then how you slowly over time get to your low carbon goal with the projects. Any questions? The high impact measures that we found, specifically heat recovery, came out on top. Adding heat recovery was the biggest, was 34% emissions reductions overall. So that piece was huge. Activating your heat recovery sounds like another one, apparently new to me. Replacing the gas boiler, ice resurfacing machines. A lot of this we've talked about. City of Burlington, the presentation was great because it went into much more detail than I am. This is a high level. Building automation system, another one I'm going to make a plug for. We found a lot of municipalities didn't have one that covered the whole building. This is a key component. There is funding through FCM. They give you a grant to take a first look at your energy management system. So you might use that to add a little bit, do a little addition piece there. Then we've got the cold water resurfacing, and then obviously PV. Those are big measures. While I'm here, I will say we looked really hard at geothermal. We did a lot of modeling and testing and could not make it work in an existing building with an ice rink. We just couldn't make it work. We did take a look at that.
And out of curiosity, was the challenge again, the huge amount of heat that would need to be stored somewhere that would imbalance the system?
Yeah, it's the
Okay.
system balance. Again, not the technical person, but definitely we worked very hard to try to make it work. And it's the balance in the system.
And that balance.
Yeah, it's balance in the system.
And just out of curiosity, the next project you're doing, I think it was, is it looking at arenas and swimming pools together? The two of them?
So we're looking at swimming pools alone, but also if a municipality has an ice rink and a swimming pool together, which is ideal
Yeah.
for heat recovery, we're looking at those as well. I don't know off the top of my head how many have both, but I know we were looking at that as much. Okay, so these are some of our early wins we found from operational savings. Optimizing ice temperatures based on activity level and occupancy, pretty obvious. Ice thickness. We found when we went in to do this site visits, we found that there was wide variations in what was actually being done. So kind of following the standards that are out there is a good first step. Adjusting humidity, scheduling building systems, which again, you need your BAS to do, lighting levels, and then reducing your water for flood. It's great that, HRII has gone, but training is huge. Operator training we found was a huge functional piece in this. And we talked to a lot of our member municipalities about the importance of that. And they're telling us actually.
Does Orpha, they provide a lot of training, don't they?
They do, yeah. It's a great question. And
Okay.
I think there's sort of setting your internal, and Adam, I think, talked to us once about setting your internal standards as a municipality and how you operate your buildings is one thing, because you set when you move from occupied to unoccupied, and if there's a scheduling shift. So there's a bit that you have to do, and then training your operators on what the protocol is. Don't switch to manual or whatever. the protocol. So there's wide training, like general training, and then there's specific training for that particular building. Plug for BAS systems. Not very much remote access. That's just, I'm speaking to the crowd here. Like, you know, all these problems, we're just telling you back. Classic kind of consulting moment where we tell you your own problems. Different BAS systems in each buildings. None of them are remotely controlled. They're not integrated. You got one that's embedded within the refrigeration system that doesn't talk to the other systems. You know, all of these. So really having a strategy for your BAS system is everything. Yeah, just reiterating that. There was the capability of capturing trends this is a bit like the heat recovery. A lot of the refrigeration systems were able to capture trends and weren't, and no one was looking at them. So your building is giving you data, you can use it. Sometimes you don't have to add in additional points on your BAS because it's there, you just have to capture it and use it. So on our plans, we often had implementing a BAS early because that allows you to control what comes in after and what you've got right now. Yeah.
Sorry.
Just to add on that, we've had two buildings, not in this cohort, that we've added building automation to. And we initially did it over renewal because they were old. But after the savings that we realized from the automation, we could have justified it on an energy management perspective. And those BSs are between 300 and 400K. So you need a larger building, but if you have large buildings that do not have an active and a new building automation, there's a business case from an energy perspective to install them.
And you had really, really short payback, didn't you?
Yeah. So it was a couple of years. It would have maybe 4 or 5 years for 70, 80K a year.
So even if you're still operating under your 5-year payback model, that, yeah, a BAS can pay off. Okay, thanks. Yeah, so some of this adding heat recovery. I sound like adding heat recovery. There was a huge piece around heat recovery. Ice storage, and I think we were talking, I think Janae can talk to battery storage. This idea of storage when you don't need it is going to come into play more and more as we go forward. Using VFDs, that's another piece, and optimizing of sequences. So there's a lot that can be done in these buildings even before you start capital retrofits is what we found. Oh, okay. So I realized, sorry, I have all of the technical details in each of these slides so that you can take them away. I'm not going to go through them in detail, first of all, because I'm not the person who knows everything about this, but if you are interested, I'll just flick through them pretty quickly. But these are some of the findings that we found, key measures for heating. And we've done key measures for resurfacing, key observations, some things replace with electric equivalent, ventilation, optimizing AHU, RTU, operating sequences, et cetera, and dehumidification, renewables, and this is a visualization of the renewables. Yeah, this is a piece where we talk about how geothermal, we looked at geothermal, solar wall, solar thermal, and none of those made sense economically. Envelope, we looked at low-E ceilings in particular and wall envelope insulation and didn't find not a lot made sense from an economic perspective, but we did it where we could. And then reducing the use of water and lighting controls. So our lessons learned from this, is getting organized early, gathering your building data. We spent a long period of time. And if you've already started down this process, we spent a lot of time just gathering data, drawings, documentation. Those things are missing for a lot of buildings, especially the older you get, the further away that was. We have funny stories like the key piece of the drawing has been ripped out to put someone's chewing gum in or whatever. Oh, right, that's where the compressor is. Getting everybody involved. Everyone had presentations before me talked about this. It's so key because you're getting your whole organization, you're getting the whole municipality involved into the integrated design process. The life cycle costing, we did work with procurement and others to start introducing the idea of life cycle costing. Operational, for the low cost, no cost measures, we put those first, and heat recovery, if that was available. The integration of the refrigeration plant with those systems, BAS, and then again, heat recovery plug. So,
And I might just prove my ignorance on this one, but I was thinking about the heat recovery. If for the heat recovery where it's used, where is the waste heat going? Is it going back into the building for the heating of the building?
Yeah.
Okay. And isn't it a lot more heat that you need than just for heating? Like, is there other, like, to maximize your heat recovery use, would you have to have a neighboring building to be able to take that waste heat? I was just curious, maybe that might be one of the reasons, or is all the waste heat able to be replacing electricity or fossil fuel heat in the arena?
I don't think so. And I'm, once again, have to get back to you, and obviously it's going to be case specific because a lot of it depends on piping, like how far is it from, like if you're trying to heat the seats with the waste heat, how far are they from the refrigeration unit, et cetera.
Okay.
And there'd be heat loss along that piping. Sorry, apologies, this is not a technical explanation, but my understanding is it's
It's a
very
matter of the
situational.
logistics to figure out where
Right.
you can use that waste heat potential, and where you can use that waste heat potential is likely to vary from building to building. or
Exactly.
arena to arena. Is that correct?
Correct,
Okay.
because almost none of these existing buildings were designed to take advantage of heat recovery.
Okay.
Whereas in a new building, you would. But these were not designed that way.
Mhm.
So it will vary, but it would displace heat that otherwise you have to find. Yeah, it's going to be a
Okay.
boiler, it's going to be an electric boiler, it's going to be some other way of creating heat.
Thank you. Oh,
Yes,
To some of the participants in this study, is there an opportunity to use the heat recovery in like coupling it with the air source heat pump somehow to sort of use that heat to boost it during like the cold winter months? Did that come up?
I love that idea. But for ours, we have a de-superheater that used to be used to heat the underfloor. Because you have to make sure you don't have a frost loop, but that heat is way more than that's needed. So it's decommissioned. So what we're gonna do with that is we're gonna preheat all of our water or our domestic hot water, because that's a good source of heat. But what you're saying is, can you use the heat from the compressor system to supplement an air source heat pump system when it's really cold out?
Okay.
And that would be the ideal solution, because then you can conceivably use your rink to power the heating system of your building when it's really cold and not have any augmentation, which I think can be done, but that's an engineering thing.
Sinead will know.
oh, sorry.
So we're doing that in the a net zero retrofit right now at Susan Fennell. So the geothermal system's designed to take in the ground source system. It's going to take in the heat recovery from the CO2 chiller plant. So in winter is going to be helpful for us. And as Adam mentioned, it's also going to assist us in the secondary hot water and domestic hot water heating. But in summer months, we're going to have to dump that. But the challenge with that is we're realizing with the eQuest modeling is you can't dump too much to the ground because the balance gets a little bit wonky. So you're going to have to look at like all these interactive measures and what is the best solution.
So we know of one of our participants that's implemented heat recovery. We saw drastic energy reductions, and especially in greenhouse gas emissions. So we're going to loop back and see if we can do a case study on that because I think we're all really, really interested to see how this actually works out in practice, because it seems finicky. Like it's a bit like any of this when an existing building, it's not straightforward where you can design it right from the beginning. In a new building, you're really going to have to work with what you got and how you adapt. So stay tuned. Okay, this is some of the information we collected around getting organized. If you're just everybody's at a different stage. Many of you are well down this path, so perhaps not as useful for that. So one of the neat things about working with FCM is they produced this, they took what we learned and created this, taking your indoor ice rink to net zero. So everything we learned through the pilot is available in this guidebook. It's free to download from FCM, and FCM is now offering CBR advisory support services. So for free, you can get technical support as you go through both the feasibility application and implementation process. They're hyper-focused on taking all these feasibility studies to implementation, as I'm sure all of you are. So they're really focused on how can we accelerate moving from doing a study, and it's nice, and then we put it on a shelf, to let's get going on actually implementing. So that's, I think, any feedback anyone has on how that can be accelerated and what they can do, I think they'd be really interested, and I think we would be too. So yeah, it's just on their website. Okay, so what's next? As I mentioned, we have a cohort project for net zero ice, so net zero swimming pools. So we're looking at that first. We see some recommissioning activities already because they were recommended in the study. So a few of our ice rinks are actually moving forward with implementation. I can speak to this one. This one's happening at the Township of King, and they're already doing a recommissioning project with FCM funding. And really looking, and that was a pretty new facility, but even new facilities don't always get commissioned properly. So this was an opportunity to recommission and really look at how to bring their energy use way down so the retrofits are small. We are going to launch a recommissioning cohort project in the fall. So stay tuned for that as well, working on that one. And then we're going to, as we said, do case studies on heat recovery installations. I have a couple more things I want to talk to, just a couple plugs. We do have free events coming up where we try to tackle some technical stuff going forward. We have one on air source heat pumps coming up in June. I believe you guys have already put it up on your website, so easy click through. We're going to look at geothermal installations in September, particularly, and we really focus on municipal ones. One thing I've been talking to about, and Adam already talked about this already, is what we're hyper focused on as well is ECDM plans. Your ECDM plan is essentially your roadmap to 2030. And that's how critical we're on this critical path now, where if you have any 2030 goals, this plan is it. That's really what you're going to be doing to get to your 2030 reductions. Canada has very aggressive goals, the 40% reduction from 2019 baseline by 2030. So we know there's going to be another round of the retrofit funding coming out. There's a lot of focus on getting buildings to lower emissions, and that's going to just increase in the next 5 years. So being ready with a plan is going to be everything. So integrating that. We know the other piece that's really a key focus for us right now is we're finding that new buildings don't turn out as designed. We've been looking at hospitals for maybe 5 years because there was a big, huge P3. This isn't quite municipalities, but it's relevant because you're building new buildings. There was a huge P3 development where there were a bunch of hospitals built. And what we find, and this is just criminal, is that a big port, like 30% of them, are way worse than your existing buildings in terms of greenhouse gas emissions and energy. I can bring you the benchmark chart, but it's just, some of them are fantastic and top performers and really great examples for case studies, but some of them are like 3 times, 4 times more energy use than your average hospital. So we got to fix that. That just can't happen. We don't have room anymore to do that. So that's a piece, and codes and standards are going to start to play into that. I know Gabby's probably talked your ear off on codes and standards and green standards, et cetera, but I think we're seeing a lot of movement to bridge that gap. So that is it. Does anyone
Were
have
the
any questions?
buildings not like you mentioned the P3 in the hospital system, right?
Yeah.
And was it about, is the challenge on it the difference between the design and the builds? Or is it in the operational functioning of the building once built? That could be addressed by commissioning or recommissioning. I was just curious to see where we're falling down or in that kind of hospital with the hospital new builds.
I'd like to say, oh, it's a really easy answer. that we
Right,
can fix.
it's not an
But it's-
easy answer.
Every case is different. We know that the top performing hospital had the operator at the table from the get-go, and they had the metrics that you can get from ASHRAE and the kind of metrics we just showed. They had those metrics when they went in and said, we don't want you to be over designing, and they pushed them every step of the way to think about the operational energy and the operational greenhouse gas emissions. And that doesn't happen as a matter of course.
Okay.
Because similar, as we've been talking about this, capital and operations, usually operators are nowhere near the table when you're building new. And Adam had a lot of great examples where he just needed to intervene correctly at the right time, where that makes a huge difference in the outcomes. And it's that early intervention that didn't happen. The other piece is that we've given this kind of presentation when we look at benchmarking of new buildings to architects. Nobody ever tells them how they come out, how they turn out. So they keep doing the same thing over and over again and not knowing how they turn out. And that we need to bridge that gap too, because we need to tell them as building owners, that's not good. That's not working for us. And if it's, whatever it may be that design wise isn't working, we have to get that message back. Because unless they don't know, they just keep doing what they've always done. So that isn't getting back either.
Thanks.
Yes, Janine.
I'd just like to make a comment on what Adam mentioned. I think a lot of us, we've made this mistake. We overlook BAS systems, and for the existing BAS systems that we have, we overlook recommissioning. And we've discovered that with a lot of our new build projects, BAS commissioning might not be one of the top priorities for the construction managers. So I think recommissioning is one of the first things that we should look at in terms of a low cost, no cost measures. That we've personally made a mistake with this. So now we're sort of prioritizing it more and more. And we used to think that we're going to get less benefit out of this, but turns out that we have to look at our whole portfolio and reassess. So just wanted to make a comment on that.
Yeah, I think if I can say something too to that, we have great examples from the commercial office sector where they're brand new buildings where they just put everything on one panel and you can't sub-meter any of it too. Like, I also want to make a plug for sub-metering things correctly when you build a new building too, because I can't tell you the number of buildings we go into now and you can't even understand like they can't separate their energy use into the different spaces because someone just put everything on the same panel. And that seems so obvious, but the electrician, like they had it in the design, but in implementation, the electrician just went in there and put everything on the same panel. But then you're left with a building you can't have the level you wanted to have really, really good, deep understanding of how your building worked, and you've lost it forever, right? Because it's too expensive. Go ahead, please.
I'll just share a lesson learned regarding the recommissioning as well. So we did recommissioning for a few ice rings, and what we learned is there was a lot of issues that came up they had identified, but a lot of the fixes were related to you need to add a BAS because unfortunately there's no way your operator is going to be able to make these schedule changes because the only controls up on the rooftop, and it was all ice rings and we didn't have any integrated BAS, very basics, and so yeah, it was like, okay, just move forward with the BAS as opposed to, and then maybe the recommissioning would have been more useful after for us.
I guess I'll just mimic the same thing. We had a number of recommissioning activities. They come in, they try to test all the sequences, and they're like, we're clicking on this BS point and nothing's happening. So the recommissioning activities weren't as valuable because they couldn't actually test the functionality of some of the equipment as well as they could have. And then what we did as part of the outcome of those recommissioning activities was identify what the cost for the upgrade of the ABS would be. We put in the capital plan, and then we implemented the BAS project as part of capital work. One other thing that we're doing, and Scott's leading, is we're doing some internal commissioning on projects where we haven't finalized it, but we're gonna have a framework that, depending upon the sophistication of the particular project, we're gonna internally commission projects. And then that's just in addition to the, the contractor and consultant functional testing. If there is a third-party commissioning agent, what type of testing are they doing to verify? And we're finding that exercise in itself, checking the specs, checking the equipment, we find a lot of problems at the beginning that were missed. And even a good commissioning agent, they might test 20% of the points or whatever it is, and they might just happen to miss a certain functionality issue that we catch, and then you can get a fix at the beginning of the capital, project, as opposed to 2.5 years later when you have to lay out some money.
Any other questions? Okay, thanks very much.